to the second video in a series about the analysis of N-of-1 trials. Before we start with the actual stuff about doing the Bayesian statistics itself, I first want to get into some fundamentals of R. For this assignment you can use RStudio Cloud, which is available on rstudio.cloud. I will explain a little bit how to set up the environment and explain some basics of R so that you understand a little bit more of what's going on. So first, let's log in. When you open up RStudio Cloud, first what you will see is your projects in a workspace that you've selected. On the left hand side you see a sidebar with some useful information. First let's go to our workspace where I've created the self-study assignment N-of-1 trials. We'll be opening up this project. If you are new to this page, if this is the first time you open it, you need to create a new space, give it a name. You can also adjust the name up here, and then it will launch the RStudio environment in your browser. So you don't need to install any software, it'll just open a project for you. Granted, this takes a little bit of time. The RStudio Cloud is still in its beta phase, so the first time you launch it, it takes a little bit of time, but it's actually quite stable once you have it up and running. So deep down, R is just a calculator. If I put my cursor on the line, it can be anywhere on the line, and press Control Enter, it'll execute the code. So the first part here, this is a comment which I've indicated with a hash, and it tells R to ignore this. The second part is the actual code. It says 1 + 1, R returns a 2. Easy, right? So just a calculator, remember this. You can assign stuff into what we call a vector. So for instance, I type this sentence between hyphens. It stored this, and I can call this again with Control Enter, and R returns hello world, which is the contents of the vector called hello. And this is the most basic data type in R. It's called a vector. A vector comes in different flavors. So we can have something that's called a numeric vector. This is my numeric vector. I could just type it into the console window with the C, it stands for concatenate, and a bunch of values separated by commas. If I do this, R returns a vector with 3 times the element 1. I can also assign this. I could type it into the console, my numeric, and assign, which is what the little arrow is called, to the concatenate. And now you see it doesn't print anything, but if I type my or print my numeric, I can select it because I've stored it already, it'll show the contents. I can also do this in the script, and it will just overwrite my numeric. If I ask for its class, it'll say it's a numeric vector, which means that its contents are any real number from minus infinite to positive infinite, including decimal places. I could say type off, and it's double precision. There's also other flavors of vectors where, for instance, we can have what's called a character vector. And a character vector is something that holds alphanumerics, so text basically. Then there's something that's called a logical vector, which holds values indicating true and false. Then there's a special flavor of vector, which is called a vector. So if I turn this my character vector, which has the contents A, B, and C, into a vector, and I print my vector, I still get levels A, B, and C. But if I look at it at its class, it's a vector. Look at the type, it's an integer, and an integer is something else than a character. It's a number, because if I type off my character, you see it's a character, so it's different. What happens is that the vector turns these characters, so A, B, and C, into numbers. So if you look at the structure of my vector, you see it's a vector with 3 levels, A, B, and C, and its numerical values are 1, 2, and 3. And these are the most commonly used flavors of the vectors. Vectors are nothing more than simple lists where each element is of the same type. Then the next type of data object that you can have in R is what's called a matrix. And here I have a little bit of code to create a matrix where basically I repeat my numeric, which was, if I print it again, just to remember, at the numbers 1, 2, and 3, I repeat this vector 3 times, and I create a matrix of 3 columns and use the by row statement to make sure that it's stacked like this: 1, 2, 3, 1, 2, 3, 1, 2, 3. So basically a matrix is a stack of vectors, or conversely, a vector is a special kind of matrix with only 1 column. I can also create a matrix out of my numeric, my character, and my logical, for instance, which are, again, each is a vector with 3 elements. We have 3 numbers, 3 characters, and 3 logical values. And let's see what happens here. Now we don't get numbers, but because my character is a character vector, R coerces all the other values into characters as well, which is the most free kind of content that a vector might have. So all of this is now character values. We can also try this with a vector, and let's see what happens. Now R coerces this into a numeric again, where this is basically the same as my numeric. The vector of my vector, its levels are, its dictionary is removed, so the A, B, C values are turned into the 1, 2, 3 values. Remember, it was an integer, which is also a kind of number. And logical is turned also into a number, where 1 stands for true, 0 stands for false. So this is basically what a matrix is. A matrix is a collection, a stack of vectors, all with the same kind of type. And then there's something called a list, which is one of the most flexible objects in R, where you can have a list can have all sorts of different content. So here I have a list with 2 elements. The first one is my numeric, which is numeric, and the second one is my matrix, the last matrix that I created. And you see that these can even be different sizes. In fact, you can store anything in the list. You can even have a list of lists. This is very useful in R. We won't really encounter it that much, but you'll see the list call in some of the models that we will be calling when we create a Bayesian model. So lists are very flexible, and that's why we can use them in R. And then there's a special kind of object, which is called a data frame. It's somewhere between a matrix and a list, where if we create a data frame and print it, we see that this data frame, and we get its structure, that all of its elements are of the same size. So the numeric, the character, and the logical, they have all 3 values, but their type is retained. So my numeric stays a numeric variable, my character stays a vector variable, and my logical stays a logical variable. So the data frame is kind of like a matrix, but it can have different data types in each of its columns. So that's a little bit special about the data frame. Also, what we notice is that my character, it was a character vector. So remember, if we ask for type of my character, it's a character. However, in the data frame, all of a sudden it's a vector. How can this be? So let's ask. If there's at any point something you don't know, you can just type a question mark and the command, which is a command name, which is data frame, and we can get the help file. And here we see in the help file uses that there's this argument called strings as vectors, and the default sets string variables as vectors. So it means that my character vector was automatically transformed into a vector variable. So that's good to know. For the next bit, we'll be installing a couple of packages from the CRAN mirror. I've already have this for you. The CRAN mirror is basically the repository where all vetted packages live. And we first install these packages, and then one of these packages which we use is DevTools, and we use the library function to call this package DevTools so that we can use it. We see a bunch of red lines. This is no problem. After we've done this and the DevTools package has been installed, we can use it to install from GitHub the library called Rethinking. And Rethinking has been created by Professor Richard McElreath, and he is really one of the most respected teachers of Bayesian statistics, and a lot of the materials in this self-study assignment are actually from his book and his website, so I do recommend that you check it out if you find this stuff interesting. With that under a belt, this is more or less what you need to know about R before you dive into the assignment. If you want to know more, then I do recommend that you check out the primers page on the RStudio Cloud website, where there's a lot of stuff that you can dive a little bit deeper into R and really how to work with R. The basics, go to the programming basics, and you can review what has been in this video thus far. So the next video we will be diving into the analysis of N-of-1 trials, and we will be continuing with distributions and variables. So thank you for your attention, and see you in the next video.